All right, you will need to get the notes out yesterday from class yesterday. And yesterday in class, we completed the whole front paper of the guided notes for pedigrees. And if you turn it over and you look at the back, you will see we're going to do the second page today. On the screen, it says pedigrees and traits. And on your paper, it says using pedigrees to predict traits. And right underneath there, there's a place for you to write down this information. Pedigrees are most useful when, and then you'll need to write down, when analyzing a family's history of genetic diseases and traits. And then underneath that, you'll also write, we can also predict if future family members will inherit a trait or a disease using a pedigree. And we're going to look at some examples. Now, example number one, I would recommend that you pause the video and just try to do example number one, and then restart the video and see if you did it correctly. Also, I recommend that you pause if you're not done jotting this information down from the screen. Pause it and restart it when you are ready. So here we have an example number one where it says the pedigree below shows the inheritance of handedness in humans over 3 generations. The allele for right-handedness, capital R, is dominant over left-handedness, lowercase r. The shaded individuals below are recessive for handedness. So, for instance, I know, remember this is a male, it's a square. This is a female, it's a circle. So here is our male square, here is our female circle. Well, I know that this female, because she's um, left-handed, and I know that she's left-handed because they shaded her in, and that's what we're studying here. Both of her genes must be for that little r, for a left-handedness. And I can go through, and anybody in this family that's shaded, that's true for them. They carry that gene that says that they're right-handed. And there's a couple of questions that you have to answer. Number one says, how many generations are there? And there are, let's see, how many generations are there in this pedigree? You should be able to identify, here's the first generation, here's the second generation, here's the third generation. So there are 3 generations. How many individuals are left-handed? Let's see the shading. 1, 2, 3, 4. And which individuals in the third generation are right-handed? So remember, you're shaded if you carry the recessive trait for being left-handed, or not just carry, but you are left-handed. So that means these 2 people here must be right-handed. And specifically, the people are generation 3-1 and 3-3. These 2 people here. Remember, we can refer to specific people within a pedigree by using the generation they're in and then the number that they're given. So 4 says, what is the genotype and phenotype of the individual I2? Now remember, right-handedness is recessive. So you will only show that if you carry both recessive genes. So we know that the girl, I2, is 2 little r's, and her phenotype is that she is left-handed. And then we have here, it says if the father, this guy right here, the square, is heterozygous. So I'm just going to go ahead and write that down. Heterozygous, so he carries the right-handed gene and the left-handed gene. What is the genotype of his 2 children? So his 2 children is this person and this person. So again, he's right-handed because he carries this trait for being right-handed. Um, so the dad, his first child in the second generation one carries the recessive or shows the recessive trait, so they must have both recessive genes. And then this child here, see, if I make a Punnett square, I can actually show it, right? This child here got a recessive gene from mom, and because that's all mom has to give away, and got the dominant gene from dad. And so That person is that. And if you want to see how they got that, dad was heterozygous, mom is homozygous for being right-handed. If I fill in my Punnett square really quick, because this person is right-handed, I know that they must have gotten the right-handed gene. Now, you will see on a lot of Punnett squares, and they opted not to do it on this one, but we could show that these people are all carriers for this trait. You know, right? They don't have it, but they actually carry the trait. They didn't do that on this particular one. So that's the answer there to that last question. And example 2 is going to be on Huntington's disease. I would recommend that you try Huntington's disease, this example first, and then watch the next video to check your answers.